Okay, continuing on where we left off from the transformation part 1 video, we hadn't finished the graph of f of the absolute value of x. And just reviewing, of course, up here in the top left corner, we had the original graph of f of x. You saw that it had some control points, if you would. But what was so very different about this last problem, as we're looking right here, is that right now we're dealing with the absolute value of x inside of f. That must be performed first. And you might remember just recopying the table of the original function just for the sake of space. We had this over here. I made a quick mention that when you're taking the absolute value of 0 as well as positive numbers, you would get those positive numbers back or 0 back. So really what we're seeing is 0, 1, 2, and 4. When we take the absolute value of them, we're back at 0, 1, 2, and 4. We would just arrive with the same y values. We plotted that out. In other words, the graph of the original function is going to be identical as long as you have non-negative x values. But something very different is occurring. We began to talk about what's happening, say, at -3. When we first take that absolute value of -3, it is transformed to +3. And then the real question is, what is f of 3? Well, we don't have that on our table. But what I do want to point out to you is that we can see right here that, f of 3, it looks like it might be located over here. You might guess if that could be perhaps a y value of 1. By the way, looking at this segment, which would of course have a slope of going down 2, right 2, that means we could also go down 1, right 1. Indeed, it would have a y value of 1. But more to the point, I guess what I really want you to see is that for any negative x value, the absolute value will be performed on it, and then we can see very quickly that really uh, those negative x values will be transformed into the equivalent of positives. So here's something kind of interesting. I would, in fact, get at -3, let's see, 1, 2, 3, we'd be up here at 1, much the same way you'd have 3 comma 1. But my goodness, you know what would happen if I plugged in, say, -2? Well, the absolute value of -2 is 2. And then what is happening at f of 2? Well, f of 2, we know from this table over here, is 2. Do you know what we're going to see very quickly is that, we can plug in, say, -1. The absolute value of -1 is +1. And very quickly you can see that f of +1 is 0. My goodness, something that's surprising. Our original graph didn't even have an x value of -4 on the original table, but I could plug in -4 into this formula, into this equation, because the absolute value of -4 is 4 itself. And what is f of 4? It's 0. So my goodness, what you're going to see, amazingly, is that you will get the graph that you had to the right of this y-axis, and it's going to be reflected over that y-axis into that second and third quadrant. Let me give you another bit of help that might help you see this. I'd like for us to look at another function that might be a little bit more familiar to you. Let's take a look at a function that I know you've seen before, the graph of the natural log of x. And to help you out very quickly, let's even graph that on the graphing calculator. I'm going to maybe just hit zoom decimal perhaps to have a somewhat friendly window. And here's what the graph of the natural log of x is. We could certainly look at a table very quickly and see that, of course, you can't have negative x values substituted in. You can see that you can't even have a 0 substituted in. But you know, that's just stating the obvious. This graph would only contain points in the first and the fourth quadrant. That is, points to the right of the y-axis. But let's just say that I wanted to take the absolute value here, and the absolute value could be under math number. And let's just say that we took the natural log of the absolute value of x, very similar to f of the absolute value of x. Let's graph it and see what's happening. All of a sudden, you're going to see that points that were not present before are now included. You see, I wouldn't have been able to work with x of -1 plugged into the original function. But you can see, even when we go to our table here, you can see now 0 is still undefined, but I'm allowed to have negative values of x plugged in. So just helping you out real quickly, what did the natural log of x look like? Well, roughly something like so. But much like we just saw a moment earlier, when you're taking f of the absolute value of x, what's effectively happening is you are going to take the portion of the graph that really is to the right of the y-axis. That is the graph that occurs for non-negative x values. And you're going to reflect this over the y-axis. So you can see what's really going to happen with that. That's really what we just saw in that last problem. So just wanted to talk about it a little bit, kind of an interesting occurrence that we can have. But really that's all I wanted to talk about, except for one brief other mention. Uh, this is something that we could talk about briefly. What happens if you were just adding a 1 to f of x? This takes f of x and moves it up 1. It's not an X-file situation here. We dealt with addition and subtraction of numbers when it was inside the parentheses right next to x. But if you should ever have an addition or a subtraction outside that's affecting the y-coordinates, all your y-coordinates would have a 1 added to them. That was one last type of problem that we really didn't speak through. Hopefully you've seen all this before and it's coming back to you. We're going to pick up next time with some piecewise functions.